Okay, good morning everyone. So I guess we can begin to get started. We're already 10 minutes late, but I guess it's not a big issue. So this morning is a working session. It's more related to the non-specific activities of some of the projects you've been looking at. The first, we will look at the data and then stuff about policy in future. So the idea is to, let's say, collect some of the things that you're doing in terms of data management, and also get some feedback of what you think and what you see in the project to understand how we can go forward with that in the future. So not to waste any more time, but I guess we can go with the first presentation. Will be from Professor Stathis Bouzias from University of Patras. So he will go through the, let's say, the approach to data management and how that is proceeding within the project, and some things we need to be looking out for and hopefully resolve in the future. Because if I can, while Stathis is coming, recently I was at an event with the European Commission organized at EGU in Vienna, and some of the other projects were presenting there. Other projects meaning the projects like ERIES. One of the things that I'm noticing is that as a community, let's say seismology or climate people, let's say measuring the natural world, one of the things is they're very advanced when it comes to data management and data infrastructures and things like that. So much so that when you reflect on, let's say, the engineering community, it feels like we're maybe one or two steps behind in that. So this is a good opportunity to learn some things about maybe non-technical aspects, because that's becoming more and more important. You see these things like FAIR, I think it will be mentioned more than once in the presentations to come, that gets mentioned quite a lot in calls, and the idea of not adhering to that or not meeting those requirements is not something that will be acceptable, let's say, in the world for the near future. So I guess we can welcome Stathis to the stage.
Good morning, everybody, Good morning, everybody, and following a great dinner we had, thanks to the organizers this morning, I have the difficult task to bring you back to a very down-to-earth issue, and not a very pleasant, very appealing subject like the data management. But as you will see further on, this gets more and more importance, and we have to deal with it. So we will see why we have to treat data as an asset, what data management means, what are the initiatives at the European level that have been mobilized towards this direction, and what can we do about management, and what do we already do about managing the structural experimentation data, which is a main output of the activities of our group. So just like any other type of asset, the value of the data increases with request. Apart other benefits and apart other similarities, I will stick to the most important ones. So the more the data set is requested, the more its value increases. And moreover, the data sets require protection and management. But unlike other assets, there are also some particularities to the data we produce, that they do not deplete with time. Their value remains, and we use it additively with other data sets, so we can draw more conclusions, and as all these new technologies about data management and AI and the rest get more and more important, they need more and more data. And the more we share these data sets, the more their value increase. So managing and diffusing, this is also important, the data as an asset. This enables organizations to unlock a full potential for innovation and sustained value creation based on the data we produce. But proper data management is not a goal by itself. We don't do it for doing it, just for this reason. It is a key conduit which leads to knowledge discovery, innovation, knowledge integration, and reuse. All those aspects are very, very important attributes of the data sets. And based on that, a European partnership was founded in 2021 as under the title of European Open Science Cloud. This is an initiative which provides a framework for aligning research and innovation at national, community, and international and institutional level. And the backbone of all this story is that we want, and the depart on this direction is to create a web of fair data. We will go through the fair issue in a while. And this web of fair data would serve all disciplines, domains, and societal sectors which make use of data and data sharing. So the scope of EOSC, the European Open Science Cloud, is to create an open, trusted federation of research communities and related infrastructures, which are supported by specific tools, and mostly, and all of them are cloud services. This will enable the researchers to store, share, process, analyze, and reuse research digital objects, as it is the generic name of the data sets. So we had to have fair data publications and software. And to do that, we will be using services which are operated and supplied by those research communities. And there is an EOSC marketplace, as it is called, in which we can find several tools that have been developed towards this direction. It's a serious initiative. If you note if one notes also the budget which is behind that, this is almost 1 billion. And this EOSC has a tripartite governance, which comprises the European Commission, 2 Directorates General, the EOSC Association, which is a non-profit organization which represents EOSC stakeholders, which comprises 166 members and 91 observers. And there is also an EOSC steering board, which is a European Commission expert group, the members of which are representatives of the member states associated with Horizon Europe. And there have been some key KPIs, some key performance indicators. I just marked what is targeted for 2025, that 80% of the total publication record by 2025 should be immediately open from EOSC members, and some other indicators. I don't know if the Commission has an idea how this has been achieved or not, but this is the goal, and the ultimate goal is in a couple of years to get this number close to 100. So we are getting close to the deadlines, but maybe we are not getting close to realizing the targets. The composition of the EOSC comprises 32% of universities and other education organizations, 28% of research, non-profit organizations, 26%, and some with fewer, lower percentages like public and industry. And on the right-hand side, you can see the geographical coverage of the members of this EOSC initiative. How it works. The idea is that we will create a federation of distributed systems which are combined into a system of systems. And this system of systems will have nodes, EOSC nodes, and these nodes will be cloud-based, will be interconnected, and most importantly, they will be able to collaborate and share and manage information resources within disciplines and across disciplines, across different thematic and geographical research communities. So these tools will enable us to collaborate better, to discover data from different sources and combine these sources, and tools will be available for this reason. These EOSC nodes will be the entry points when we enter into this EOSC constellation, let's say. And on the right-hand side, you see the EOSC Federation Handbook that has been produced. I will not go through many technical things. I will just show you that there is a considerable number of EOSC projects going on in several disciplines like fishery, cancer research, and many other things. Some of these also focus only on developing technical tools. There are quite a number of those. And another important issue is that in every call, but more specifically, those calls of the European Commission which are related to research infrastructures, and including the one we participated in, we have ERIES, which ERIES falls into, there is a specific request that we should duly address data management, interoperability, as well as connection of digital services to the EOSC, which means we have to start opening our data, connecting our data with others using these EOSC tools. And beyond technicalities, how we will do it and what some things are, there are also some other things we have to take into account. Let me just remind you a couple of things. As humans, we have an intuitive sense of semantics. We can see a web page, and from that we can understand the context, we can understand structural, visual, or iconic cues in this web page. And we can understand the context of narrative nodes. But we are unable to expand this to the scale that is necessary, and it corresponds to the scale of the data we produce. So the scope, the scale, and the speed that we need to manage all the production of scientific data is not something that humans can do it individually or by hand, so we increasingly rely on computational agents. And these computational agents, they need to be capable of autonomously and appropriately act and discover these semantics that we can understand and identify more easily. And they have to have mechanisms and protocols to do that. And also, they must keep a record of the provenance of all this data. So the authorship of the data is not lost. And this means we have to assist. When we build tools like that, we have to assist them. We have to give them the specifics that they can do the work they are designed for. And one of these specific characteristics are that these digital entities should have some attributes. They should be findable, they should be accessible, interoperable, and reusable. So they should possess, they should include information to cover these aspects. Every machine actionable data set should be able to cover up these four principles. And these principles expand not only to data, but also to metadata and infrastructure. And the acronym, finally, FAIR, comes out of these four principles: findable, accessible, interoperable, and reusable. And the fairness of the data set and the metadata is a prerequisite if we want to manage properly the data and perform data stewardship. Just by making our data public and visible doesn't mean that we respect FAIR and our data is reproducible. We have to do more than that. So the FAIR principle is followed by more specific guidelines, because all the FAIR acronym is just wishful thinking if we do not go into details and specify what do we mean by findable, what are the attributes that data and metadata should possess so that they can realize the scope they are intended for. So, for example, to be findable, the data should, and the metadata should have persistent identifiers, DOIs, or other types of identifiers. The data should be accompanied with rich metadata. And this is very important. I'll come to that later on. They should be searchable. So if I need to discover if in a database, if there are any data concerning the columns, there should be a way that that these data and the metadata which are in a repository can give me this, can respond to an inquiry like that. They have to be accessible, so they have to follow standardized protocols. They sometimes, depending on the case, they should allow the protocols for authentication and authorization. EOSC has produced specific tools for that. May I remind you that later on that the labs already use a platform we created, and then they need to identify themselves to enter and produce data and make them open. In that case, they use EOSC tools. And one other important issue is that the metadata are accessible, but also they are available even if the data, finally, after some time, they are no longer available. which implies that maybe we have to keep metadata and data separately or duplicated so that we secure that they remain also for much more time. And I don't want to go through all these in detail, but for example, to make the data usable, again, if a researcher wants to use a data set that has been from an experimental study, we need to tell them what we did, how we did it, where we were measuring, why we were measuring that, pictures, video. Take yourself and place you in his position. How can you use a data set if you don't really understand what happened? So this is the role of the metadata. We have to give them any possible and every possible information in any form, drawings, text, video, about the data, not the numerical values. I'm not talking about the numerical values, but how we did the test, as if they were there, to be able to reproduce it. This is extremely important. Otherwise, the data is just numerical values, and maybe it's not used or misused. So, and if you imagine that all this is just blah, blah, may I tell you that there are also already scoring tools, which if you give a DOI of your data set or your metadata set, it can give a score, whether you have achieved the FAIR principles, every one of them. And you see here an example that a specific data set got a 75%, a high score about findability, and a moderate score about accessibility, interoperability, and usability. So we cannot hide anymore. These tools discover, and they are discipline agnostic. They function in every discipline. It's not just for structural data or it's for any type of data. Its scope is to check the fairness. And fairness doesn't have anything to do with a specific discipline. It's across disciplines. And there are cases when we discover things. For example, why did this data set got a moderate value for accessibility? The tool gives you more information. Whenever you have an exclamation mark here and an arrow here, one can go further and see why they got this metadata set or data set got a low value, low score. So things are very, very transparent now, become very obvious that we cannot escape. This is the general view. Let's see how we can deal in specific disciplines, and actually in our area, about this. How do we take into account all these initiatives and necessities? I will just talk about the first attempts and the current situation. In earthquake engineering, the first step was done in Nice, when a central repository was used for all the labs which were funded by the Nice consortium, and they had a common database, specific rules how to structure their data. I have a test, I have a project. This project comprises 5 specimens. Each specimen had 3 tests. Each test was repeated 5 times, and we got this, and we changed the configuration and all the information in a structured manner, but in a central repository, because it was funded by the NSF. The NSF imposed that all the data should be stored centrally. And this initiative was followed by the successor of NICE, the Design Safe project, where they refactored and extended this repository. But they went one step ahead. They offer very strong cloud tools, the ones also that the Commission intends to offer through EOSC, that you can work combining things in the cloud, taking information from different sources, software from one place, data sets to compare from another place, earthquake records from another place, and created a Jupyter notebook or other types of tools, usually in Python. You can perform calculations at a large scale in the cloud, combining information which is, let's say, at different nodes, the EOSC nodes that we intend to arrive at some point. At EU level, seismic engineering departed for the first time with a project series to create something similar, and that was followed by SERA. Regarding the wind engineering discipline, I only discovered the database of wind characteristics, which is the one you see. It's just a collection of data set, which is available in GitLab. But I haven't identified any community-level approach to tackle the EOS scope and ways to do it. In ERIES, ERIES was the first attempt to create a distributed database. We all know that there is a reluctance. We don't want to abandon our children, the data we produce in our labs. Every lab wants to keep, it was the tendency, has to change, that we keep the data within our lab. But the idea behind this project, which should be attributed to Pierre Pegon, who conceived that, was that, okay, you can have local nodes, store your data there, provide any information you need to in that local node, and we will build a central infrastructure that connects these nodes, and the user addresses an inquiry to this central infrastructure, and that infrastructure addresses the question to the nodes, and if any node has some information relative to this request, it returns this as an output, and the output goes directly to the user. There is no central storage of the data at any point of this situation. So the data remain within the nodes of the labs, provided they maintain it, the nodes, and they service the nodes, etc. And the central system can distribute the data. This was an excellent idea, and it was indeed realized. Also, it was followed by a data model, because when to respect the FAIR principle, you need to exchange information and provide information that comes from different labs. You have to have a structure of your data. You have to define what is a specimen, and each lab, under the word of the specimen, under the keyword specimen, it should give you some value, so that the tools, whenever they request a specimen, they don't care if it comes from one lab or the other, but your data set has to have some attributes. And a data model for structural testing data was devised, and here you see the interface of that website that was collecting information. All this information about tests at different labs that you see here was not within the central portal. It was in the distributed nodes, in the distributed labs. And this software, at that point, requested that information and presented the information here in a structured way about the project title, names, specimens, signals, etc. In a subsequent project Sera in Horizon, this system was refactored with new tools, because some time had passed. And more importantly, it was sought to cooperate with the EPOS project. It's an ERIC, it's a research infrastructure. EPOS stands for European Plate Observing System. And they had already started doing similar connection of the data of the EOS type between all seismological labs and entities. And also not only seismology, they were covering a number of about 8 disciplines, and all these disciplines, each one had to respect a certain data model, specifically for the metadata, because the data itself is different between these disciplines, but the metadata should respect guidelines and requirements that EPOS had set centrally. And all these thematic core disciplines, thematic core services that you see here, were under the same umbrella, which is this website of EPOS, EPOS Integrated Core Services, which nowadays also implements EOS tools. And the idea in Sera was to try to connect the database and the system with the architecture we had with the EPOS. So through EPOS, was it possible to access the data and the metadata we had in engineering labs? And this was really found possible because we had a series that data and metadata model developed. There was an EPOS metadata model developed. So it was just creating an interface between these two. So from the website of EPOS, one could access access and download data which were in the database of the series database. And here you see this example. This was about metadata on a project on pseudodynamic tests, etc. So it was possible to connect what exactly EOS strives for, what exactly EOS tends to achieve. And coming to ERIES, under the general notion of data management, what we tried to do, because we had to respect the call, we had to develop a data management plan which would describe how we will treat the data and how do we assure that the data is fair and all these requirements. We built a new system architecture and a platform to realize the data management plan. We had to build a new data model for wind engineering data and metadata, and finally OpenTA resulting metadata and data respecting the FAIR principles. The data management plan describes how do we treat the data, how it's structured, managed, and provided to third parties. And to do that, we used an EOS tool, it's called Argos, to develop the DMP that was developed in the first 6 months of the project. You see a screenshot on the right-hand side. But to see if we can, how do we go about the sequence? Do we keep the series database and this rather stiff system that required every lab to maintain a node because the data were distributed? We created a data management committee between ERIES and GeoInquire projects. Despite the saying that if you want to kill any idea in the world, get a committee working with it, the committee did not pay attention to that. This 4-strong committee, 3 members from ERIES and 1 from GeoInquire, tried to coordinate the synergies between the 2 projects regarding data management and interoperability, and came up with proposals to employ a more flexible and contemporary architecture for data and metadata, because also technology changes and new tools are available, so we can make the things simpler and more flexible. Use public and trusted repositories for data storage. This would secure first that the FAIR principles are respected. The data have a DOI from an accredited organization. The repository is there and secure that it will be there for many, many years. Instead, in contradiction to the picture that after 3 or 4 years, the node in the lab, one of the labs was not functioning, and there was no way to oblige the lab to do so, because the project had already ended. And also to comply to existing data models and taxonomies, like the GEM one. So it was very important, this contribution. And despite that, I haven't seen any statute being devoted to a committee, because actually these suggestions were taken into account seriously. So the old system that one has some metadata in a portal, in an access portal. Each partner has a repository on its own. Each lab has a repository on its own. And then through the series central node, a user can access the metadata or the partner data. The old series system was changed to a more flexible one. So what we did, we created a platform for this. The data and the metadata will be stored in accredited repositories. We do not need to maintain in central repository. Regarding data models that have to accompany data and metadata, in earthquake engineering, we already had this data model from series, the experimental data format called EDF, which also followed a common format created by the Commission, Common European Research Information Format, the SERIF, and the GEM taxonomy. So we try to give our metadata the maximum number of attributes. So no matter how the tools search for these, they will be able to discover our data. This is very important. And a data model for the wind engineering data also was developed. It's an extension of the experimental data format, because our experiments are pretty similar. So we came up with a data access portal, which is a central portal which does not hold any data. It just provides descriptions for individual projects And for each one of these projects, we store in this data access portal, which is a cloud actually service, we store all the metadata we want, including a DOI, both for the metadata and for the data. The data reside in another repository. And we had selected GitLab or Zenodo, practically more Zenodo, because Zenodo has many more advantages for others, but also national repositories which exist in several member states. So in this cloud-based portal, we currently hold the metadata from 17. There were added 2 yesterday before I arrived here, so the number was updated just yesterday. And these 17 projects comprise 8 projects from wind engineering labs and 9 projects from earthquake engineering labs, but only 3 of them are from ERIES. The other 8 are from past projects that some of the labs had took the initiative to store these projects, which were coming from SERA, and no one could find them anymore because the old series database was abolished and it doesn't exist anymore. So those 8 tests were transferred to this data access portal. And okay, there are several facilities here, like downloading collectively all the information about one test. And there are also some attributes you could you see on the right about the accessibility, how many downloads or views we had of the data. There is a central authentication facility, which is based on EOSC tools developed by EGI and GRDET. Which is used for the labs to enter and be able to store metadata to DAP, the data access portal. We also came up with a pretty, how can I say it anyway, not very appealing timeline of how to deal with the metadata and the data after the tests we produced in ERIES. So within some time from the end of the project, of the test, we need to upload to curate the data and also get a DOI of the metadata. This is a very important step because this is a departure point for every action later on. So we need to get a DOI for the metadata. And there are 2 ways to do it. And it used to be just one way until yesterday. And today, I'm just going to tell you that, to add that there is a modification here to make it easier to labs to obtain this DOI. And the reason is that a DOI from a data paper is just a paper in certain journals which accept that kind of papers that does not include any elaboration of numerical data, but just presents the skeleton of the tests, the how, what happened, where, and any information that one could present on this experimental campaign. One can use, for example, Data in Brief, which is one of the journals that issues data papers, Earthquake Spectra, ORE. ORE is Open Research Europe, is a platform for open access data papers that is being established by the Commission. And actually, all projects which are being funded by Horizon can, without cost, present and submit a data paper there. My experience from doing so on this platform was that within 3 or 4 months, one can have this DOI of a data paper. The other way around, because to tell you the truth also, that the data paper in the other journals, from what I saw going around these papers, that it takes about 9 to 12 months to publish. And it's a long time. So to facilitate a little bit more the situation to get the necessity to get a DOI, we can use accredited platforms like the Built Environment Data, which is a database which is an initiative by EU Center and use, and it's a platform where you can upload the metadata and get the DOI very, very fast. This respects the data site organization metadata. They are not as rich as the metadata we request in the DAP, in the data access portal. They are not as rich. But still, you can get the DOI pretty fast. On the other hand, we have to use data access portal because it's a requirement from the ERIES project itself, because we promised to the Commission that we will build such a facility and an infrastructure, and we will upload there the metadata. So it's a departure point. It's the mirror for our community, and so metadata have to be uploaded to the data access portal, but the DOI can come either through a data paper or through a BED platform. So this facilitates the situation. And having this DOI for the metadata, the lab can at the same time process in parallel and perform the data curation and upload the data to Zenodo or any other accredited repository, trusted repository, and get a DOI from there for their data, for the numerical values. There is the possibility in these platforms to apply a period of embargo, because every research team needs some time to produce some publications. So before the data becomes openly available to the public, they should have first the possibility to elaborate on this data. It was their proposal after all, and their research idea. So there is a maximum is applied from Zenodo. It's not applied by ERIES. The teams have 6 months to prepare such a publication. And then at that point, also having uploaded the metadata to Data Access Portal and to Zenodo, with the DOI, and having the DOI from Zenodo, finally 6 months after the end of the curation period, the data becomes open, it's released, so they are available to the public with full information of the numerical values which are in Zenodo, the metadata which also reside in Zenodo, but also a DOI of the metadata which are in Data Access Portal and in BED. So we cover the maximum possible of the maximum needs of FAIR, and also check how this respects the fairness of the data. The tool is pretty easy to use, the Data Access Portal. It's the labs which have access to this facility. And upon authorization, one can enter and can start filling in boxes with information and files like video, photos, etc. And this is a picture of the metrics. So I went through all the projects except these two ones which came up yesterday. In ERIES, and here you see the 8 projects from wind engineering labs and one from the structural, and here you see the fairness score. This shows how fair the data, how the data and the metadata practically complies to FAIR principles. There are some low scores here, and this is because of a technicality. For example, in this case, these metadata were uploaded to a national repository, and from the drop-down menu, one could select different attributes. In this case, it was selected collection. It was a collection of information. But this tool does not recognize collections. When it tries to score our metadata and data for fairness, they look for data sets. So just by only with this word, this score was low and could go much higher if the appropriate attribute was given to the metadata. So this is just to notify that there are serious things afterwards, because when one gives a DOI to this tool and gets a score of 50, usually it doesn't go further in to see how this 50 comes up. What is the reason? And there are other reasons, very technical and very, you cannot expect that this tool, if it takes some time to discover some data because you have a zip file or you have something which is very large and your server does not open it for the tool, within some time, within some seconds, it ignores this data set and gives you a very low score, as if that data set doesn't exist. The information doesn't exist. So there are some technicalities behind that, but still the numbers talk. Also, you can see here how many downloads and views we had through Data Access Portal and from Zenodo on these data sets we produced within ERIES, both for the ERIES tests and some of the past ones, the past projects, as you see. So to conclude, digital objects, our research data, are valuable assets and can create further output and benefit, provided that we make them open, but also appropriately open, together with all the information that one can use to elaborate completely this data. Publishing our data makes it accessible, but it does not mean that it respects fairness, that your data is fair and it will get a high score regarding fairness. So we have to provide as much information as possible, metadata type information, rich metadata, so that our data become accessible, interoperable, and reusable. And EOSC and ERIES provide tools for this, for promoting the openness and the fairness, but I have to stress that our community needs to try a little bit harder in that direction. And that's all. Thank you very much.
Thank you, Stathis. I guess a question from Michele or a comment?
May I? Stathis, thank you. I think what you presented is very important. For the reasons that you already described, and I don't see any reason to comment further. I have one specific question, one small one, and one consideration. The specific question is, do you expect that the upload of the data should be done by the laboratory that has hosted the project or by the group that has accessed the laboratory? You understand, it's quite different. And I come also to the, say, the contour part of this aspect, and that is that to count on a voluntary-based upload of data is fine, but I have learned that in many cases it's also necessary to give some more reasons to people to do this kind of effort. Therefore, I believe that in our community, which is not that large, we should keep some record of those who are actually doing this and those who are not doing this. We have other projects in the future for sure, and we should have a kind of verification of a fair behavior, something like that. You understand? This could apply to the lab and could apply to the groups that have assessed the lab. Finally, a very minor point in your second last slide. I wonder how can you have more downloads than views? 191 downloads on 88 views, 179 downloads on 87 views. It seems either they are, but then there is 7 out of 97 or 14 out of 75, so it's not just a reverse problem. I imagine that in all cases the number of downloads should be lower than the number of views, but this is a minor issue, just
yeah, okay. This is a technicality. I think it depends how the software was programmed. What does that mean? View, download doesn't count as a view, maybe. But then there is one which is the opposite. You said.
In that case,
yeah, we have to check.
In that case, the opposite is true. The download should be always.
Yeah.
Anyway,
yeah. Okay. Yeah. I will check. I was collecting that in a hurry and rather blindly, so I will check with that. Thank you. Yeah, regarding your two questions, who is responsible for data and metadata uploading is defined in the DMP, the data management plan, and there it is mentioned that both the research teams and the lab are responsible for uploading the data, but technically it's the lab because it's a longer lasting entity and it has much more inside information for this data and metadata of how to present it. But of course it applies to both to agree that this is the output of our common activity.
Okay. For me, the answer is okay.
Yes, practically, because it's a more longer-lasting entity, and it's the one which has many projects instead of just one as a research team. Now, the other thing, yeah, we keep up a record of what is happening, as you saw before, about the statistics. So practically, we know that, and we've seen that the responsiveness is not as expected. And I don't know how this can be dealt with from a coordination point of view, or what will happen in the future. But still, we see that there is. I want to be frank. There is a reluctance of the labs to open the data. In series, there were about 10 tests. Out of the 30 or 40 tests we performed, there were 10 that were published. In Sera, were less. And some labs never uploaded anything in the Sera project. And this is so in ERIES so far. We are in the third year through the project. We have just less than one more. And still having 3 projects only out of from 2 labs with data is not a good picture for us as a group and in the eyes of the reviewer of the project and the officer. And also, it makes a very bad impression for the future. And we never know when this will come up and what implications might have. So that's why I said it mildly, we have to try much harder as a community. And this will define also future activities, will define a lot what will happen in the future with earthquake engineering. It becomes more and more difficult to get funding from the Commission in our field. And if, by definition, we don't respect the needs that the Commission says we have to respect, like EOSC and fairness of data and openness of data, this is a handicap for us.
Just to, we will take some questions if there are any from the floor, but just to add to what Stathis has just said, that idea of fairness, for example, definable, accessible, all of that, that was a European project. That was EU-funded money, like made that whole system. It didn't just fall out of the sky. The same with the tool, the tool to evaluate the score. You can go and find the grant agreement. So the EU is investing in that stuff. They're building these tools to, let's say, score everybody, rate it, and make it all integrated. So it's something they're aiming towards. So the idea of just, say, forgetting about it and thinking it's a secondary issue is it's a little difficult to justify. The second point is, given how all of this stuff is integrated and digital now, when we were doing the latest review of the EU on this project, on the portal, that very user-friendly portal that the EU has for managing projects like this, you can see the data. It pops up there. So like these systems that Stathis has just mentioned, the people who have uploaded data, they pop up now. It's already, let's say, cross-referenced, so it automatically comes in there. So those few projects come in, and let's say the question was raised about, oh, you have few data up there. Okay, but the project is still underway. But we can only justify that for so long. It's not something that will go on forever. There was another point I wanted to make. Yeah, you had a slide about EPOS. Sorry, I'm adding more content. You had a slide about EPOS, for example, and other communities. This was the point I wanted to make. And to say that I understand maybe our community's perspective is that many other communities are measuring and observing things like seismology, things like the temperature of the ocean, the speed of something of the wind in the Antarctic. Let's say measuring the observed of the actual world. I know in engineering we have to build things in the lab, destroy them, and then actually go and do it again, right? So this is maybe our core business. So the idea of managing data, curating data, learning all of these acronyms, all of that stuff maybe isn't the most attractive stuff, but you can see from all of these things that that's really important, and it's what will determine the future of that stuff, because as Michele just mentioned, like this scoring, and we're appearing as bad students if we don't do this. So it's let's say penalizing ourselves, even though the work could be great in the laboratory. That's all I wanted to say. Questions, comments, difficulties?
Thank you. Just a couple of comments. Based on our experience with uploading data from some past projects, it isn't really hard. So we have to work harder, but the hard part is not the real uploading. With the latest tool, this is very simple. It doesn't take a lot of time, and we see that the outcome is very positive. And also, I was very curious to see the fairness ranking of past projects. Some of our past projects ranked quite high, and I think this is the merit of the data structure that was created in series and then improved in SERA. So this was a good investment then, and it is perhaps an example that we can follow for the future. And also I was happy to realize that something that was done some time ago is giving some good results for today's way of assessing data. That's it. Thank you.
Any other comment or question?
Thank you. So, Statis, when something is uploaded, it's difficult for us, it's impossible for us to correct it. If we want to improve the ranking, the score, fairness score, how is it possible for the users and the provider to improve what has been already uploaded?
What is locked is at some point we have to decide that what metadata we had to upload is uploaded and it's there. If we discover an error, I mean the rule is internal to how we build how do we manage this situation. We can decide, and we can do that. It's not something difficult to do. If we discover errors, to change things. The DOI doesn't change; it is the same. And if we use a platform which accepts versioning of the metadata and the data, so under the same DOI you can have one version which is the first, and if you discover something and you need something additional or correction or whatever, you can produce a new, under the same DOI you can have a second version of the data and the metadata, and you can have it. So both Zenodo supports that and we support that. The data paper is there, we cannot change it. You can, if it's a data paper, it's there. You have to do something with the editor to an additional correction to what you presented as metadata. But for what regards the data access portal, of course we can do it. It's us. I mean, we just have at some point decide that now we stop. Otherwise, we will keep on with the metadata and it will not be finalized. The users have to know at some point when this metadata is finalized. Can I download, or tomorrow they will change something? So by applying this finalization of the metadata, we place some pressure on the lab to finally think carefully and do it. But of course, we're humans, always things happen. We can change that. It's not a problem to change that. It should be clear. Yeah.
Just to add to that comment about fairness and scores, right? I think it's clear, but just to say it anyway, if your data set has a poor FAIR score, it does not mean you have poor data. Maybe the test was wonderful and you have excellent results scientifically. It means you were, let's say, you were terrible at describing it and making it findable. So you have wonderful data online that nobody can find and nobody can describe. So something as simple as keywords gives you a poor score. It's something as simple as that. It's not hard, as Yorgos just mentioned.
And also, I'd like to add, if I may, these days, these periods here, 30 days and 45 days, etc., there's a reluctance in accepting deadlines. In general, we all do. But may I say that metadata is not something you discover after the test is ended. It's being built during the course of your test. So from the beginning, you have designed your test. You have an AutoCAD drawing about your specimen. This is a metadata. You decided that you will do a first specimen, a first round at 0.25 G and a second round at 0.54 G, etc. So you already have a structure. This is the metadata. You tested the material strength of your specimen, of the material you used, 30 megapascals. This is already a metadata. So by the end of the tests, you already have all the metadata. You have the video, you have the photos. You just have to organize them. And this tool is being built so that progressively guides you through this process. You have a project. How many specimens? I have a first specimen, which is the virgin one. I have a second one, which is retrofitted with this technique. A third one retrofitted with this technique. So you already have identified 3 items. And each item can have sub-items as you go on. You had 1, 2, 3, 4 tests for each specimen. You had the demolition test or whatever. So all this information builds progressively as you go on, and our tests last for some time. It's not a matter of days. It takes months to do that. So by the end of the test, you already have all the metadata. It's just to sit down, and within 1 or 2 mornings, you can do it. I've done it, and I cannot say that it takes more than that. And maybe the labs which already done this can certify or disapprove this.
So I'm sorry to say that it doesn't work like that for us. In wind engineering, most of the time, when we begin something, we don't know where we will finish and what we will be doing. So of course, we have been declaring in advance a test plan. But actually, it was the case for the WISP project, for instance, we have been presenting yesterday. You begin with hypothesis, and you look through this hypothesis, and at the end, you focus on something. And at the end, also, for us, what happened is there have been some runs that have not been recorded. And so it's only at the end when you process the data that you can say exactly what has been done. And we reconstruct after the test plan from what we have been recording properly and what is useful, what has been working. So I'm sorry to say, in our case, it doesn't work like that.
Well, let me say this. I'm saying not that you are uploading this information during the course of the project, but you have this information during the course, the metadata. I'm not talking about the actual data or whether a test approved the hypothesis or not. This regards the data and the results that you will discuss in a journal paper for the scientific part of the project. But regarding the metadata, how you did and what you did is information you can collect during the project, and at the end of the project, the very final day, you know if you did that test and you had the data or not. So you will say that you will not present this in the metadata. But I mean the information has been built in time during the project, not being uploaded. You can start doing it in a dashboard like an internal user. You can get into this is the dashboard of a specific user. So you can enter into there, without anybody seeing what you are adding with time. So you build that structure, finally a specimen, you didn't finally realize it. You can delete it. So I mean information has nothing to do with these dates that appear in this timeline, the 30 days and the 45 days. Actually, it's the whole duration of the project that you have to create the metadata package.
Yeah, okay.
Okay, that's it. The data and whether the hypothesis was proved valid, or whether you did the 0.3G or the 5 Mach test or whatever, or you did something else, okay, fine, but you don't have to present it, I mean.
Okay. Most of the time, it's only at the processing period that we discovered that some sensors were not working properly, etc. And so we had to discard some tests due to that. But it was just known some weeks after, not immediately after the test.
Yeah, okay, but as you know, we are not very strict with these dates, deadlines. I didn't say that.
Any other question or comment? Okay, so I guess we can thank Statis once again.
Thank you very much. Thank you.
So we will pass to the second, I guess, non-technical. It's even less technical than the previous one. Presentation on policy impact. I forget what the title I gave it was. Policy and impact within ERIES, okay? So what I will do is the following. I have a couple of slides to show first, because as we were seeing before, the idea of data and the idea of, let's say, impacts are quite important to assess projects like these, because in many cases we're up against people who are in entirely different fields, have different ways of managing their data, as we just saw. So some things we can improve on there, but also how we communicate the actual impact, the value of the project. So something we notice when we speak about this with people outside of, let's say, our immediate audience is, what is the impact of this? Sure, maybe you discovered something wonderful about cement or the shapes of structures or how things behave in the laboratory. That's wonderful. But unless you can really make it demonstrate the impact and communicate that to the wider audience, it's hard to sell the value, the global value of something like this. So this is what the focus of this session today is, right? So I showed this slide already, but I'll just go through it quickly again, right? When we're going through calls and we have things like this, so the InfraServe call that came out a couple of years ago, to which we applied and were successful, these were the expected outcomes. They were expecting us to meet these kinds of things. The ideas of curiosity-driven research. It's very vague. It mentions nothing about engineering, at least directly. But the idea of harmonizing things, synergies, it's very, let's say, soft in terms of the scientific content. But it's trying to promote a lot of things. Now you'll recognize the last line there about better, fair data principles. But these are the kinds of things we're getting judged on, not how many citations our publications have. Sure, that matters, maybe for an individual or the local scientific community, but for a bigger picture of what the European Union is sponsoring, they're interested in other things, how you can make a bigger impact. Okay, so these, again, are the stats. This kind of stuff, even though it maybe took me a day to dig out these numbers and find these within all of those Excel sheets you were compiling and the emails I have from all of you, but finding this kind of data, this is what has, let's say, impact, even though it maybe seems like fluffy numbers that don't really mean a whole lot, but it's this kind of stuff that matters a lot to people. The idea of having a lot of young people involved, how do you quantify that? The industry involvement. These kinds of things are key performance indicators as KPIs, as you'll hear more and more of the near future. These are the things that we can communicate and show the value of the project in a much clearer way. So the idea, so coming back to the technical content, sure, we have research goals and research areas, and the idea of, let's say, having the intersection between different combinations of these to, say, give an overall structure to the project and try and link all of your individual activities together within a bigger scientific scheme. But we need to be able to translate that into something that has a more lasting impact, almost in a non-scientific sense, or at least in an immediate scientific sense. So this is twofold. So it's showing that the research is indeed of high quality. You know, maybe we know that, but unless you can tell somebody like your parents, your spouse or something, you know, maybe it's hard to say what you're doing actually matters unless you can show it in different ways. So the idea of saying, yes, we got loads of data, we got so many gigabytes or terabytes of data, sure, yeah, but does it really matter? This is the conversation, okay? So the impact on broader society. This idea of societal impact, but also the direct. Maybe we're more focused on the direct scientific impacts, but it's a societal one, which is maybe something we need to just be careful of. So to get going with this, I've devised a little thing to be more interactive with you. So I'm going to switch from a PowerPoint presentation over to a more interactive session. So what I'm going to need all of you to do is to take out your phones and scan this QR code. So what we're going to do is have it's like a Q&A session basically, and we should be able to see how many people are connected. Actually, I'll do this as well so I can see what you're seeing. You don't need to install any app or anything like that. It should work directly on your browser. Okay, we can see a lot of likes coming on the bottom right end. Someone's clicking that button quite a lot. Okay, someone's really enthusiastic about this. Okay, you can stop now. Okay, so I can still people taking a photograph. Okay, we're ready to go. If not, the code at the top, if you go to menti.com and put in that code, you can join as we're going along, right? So to get us started, right? Who has ever seen something like this before? So on your phone, you'll see a couple of options will pop up now. So you have the idea of, yeah, sure, I've used it. Okay, someone has never heard of this. But the idea of, oh, yeah, maybe I heard somebody talk about this. Haven't really used it. Okay, okay, I have my work cut out for me today, I think. So I can see we have 43 people joined on the sides, and we have, how many answers? Roughly that. So we can see a lot of the audience is not really familiar with something like this. I'd maybe give you a spoiler. It's not very hard, but the questions will be tough, much tougher than this in a second. But it's to give you an idea of, okay, what we're up against here, okay? So we can see that maybe a lot of the people have never seen something like this before. Some people have, and some people are, let's say, what we'll call expert users. So to give you an idea of some simple things, are you a coffee or a tea person? We'll get back to the technical questions in a second. Oh. No, it's too early for that. Okay, I think we're a predominantly coffee crowd. Again, too early for that. Okay, I think coffee is winning by quite a long shot. Yeah, I think it's reflective of that. Are you an early bird or night owl? When do you prefer getting things done? Early in the morning or late at night? I think this will split the audience a bit more. It's surprising that everybody's saying early bird, but many people were late today. I mean, there's a slight contradiction there, but okay. Maybe those are all the night owls. Okay, so we have a split in the audience there. Are you a mountain person or a beach person? I have a feeling how this is going to go. Yeah, like this. Oh, no, okay. Someone is liking again on the bottom corner. Okay, so I think we have more beach people in the audience, so I guess this could be a good indication of where the whole conferences and workshops in the future. And lastly, who's going to win the Champions League? I think this will be reflective of the Italians in the audience again. I had the 4 options, but then this would be, if someone picked something like Barcelona or Arsenal, this would be maybe a reflection of who actually doesn't follow football. Okay, so I think, I think we know where to bet our money now. Okay, we'll get back to the more technical stuff now. So I think on your screen you should be able to point a pointer of where you're working to have an idea where people are from, where you're working. It's a bit finicky, maybe it's not the easiest. Sorry, Girma, but putting the world map to have Canada included made everything too small. So I guess you have to put yourself in the middle of the ocean. A lot of Portuguese, some people from the UK, Italians, good distribution of Italians. Okay, I'm guessing that's you, Girma. Okay, so we can see there's a good distribution of people. I think we have an idea of where people are from and where people are working from the coffee breaks and from the dinner last night. So it's good to see some people. Sorry, David, I guess you're picking Armenia, which is not on the map, but okay. Okay, so we'll get back to the more technical content. So what's your primary field of experimental research? So this is where we'll see how people are dividing up between these. This is probably reflective of some of the bar charts I showed earlier, early yesterday. So yeah, we can see there's a good, I think historically or from the past projects we see, there's a good involvement from earthquake engineering. Also, we have a lot of people from wind and a few are from geotechnical engineering. I'm not sure if you can pick multiple options, but in any case, it isn't so critical, the responses. I should also say for the questions that come later, all of this is anonymous. I don't know who said what. So for some of the questions you'll see in a moment, maybe you're reluctant to say what you really think, but just beware that I won't know who said what. How familiar are you with so what you'll see is a scale, I think, on your phone where you have no idea, well informed. So how familiar with something like policy impact documentation are you? So is this something you have no idea what this is? You're an expert, you're very well informed, or it's something that you're somewhere in the middle. You've heard about it and you're not so expert. So as I expected, we're on the lower half of the scale, which is fine. Okay, it's not the end of the world. It's more a reflection of the community and just say where we need to maybe do better and understand how to communicate things just slightly differently in the future. So this is what we're up against, and it's also good to have this kind of data so that we can show for different audiences that okay, this kind of community, the ERIES community, is maybe not very well informed about some things like this. So maybe we need to do something about that. So it's also useful from that perspective. So how do you feel about policy impact? Something about, I'm all about the science. Policy really isn't my thing. I know it's important, but it's a little bit distant from what I do. I've dabbled a little bit in it, but I'd like to understand it better. Or something about, I actively shape all of my research to impact policy. Ah, okay. Okay, I was expecting more people to say that they didn't really care about this. But okay, someone is honest. Okay, so I think everybody has a good feeling that they know it's important, but it's a little bit distant and it's a little bit soft and non-technical, so it's not the most important thing in the world. And some people have maybe dirtied their hands a little bit, but it's something that they'd like to understand better. And I guess there's a small proportion here that you actively shape your research to really have an impact on policy. So that's good to see as well, that some people are up to speed on this kind of thing. In terms of technology readiness level, how advanced do you think your project is? Okay, I think it's on a scale of 1 to 9 here. So in terms of technology readiness level, TRL, you'll see this in proposals. So this is I put a diagram on the left-hand side. So you have something like 1, which is like very, very basic research, proof of concept kind of stuff. You have development and deployment. So the higher up you scale, you go up on this scale, you have something that's just an idea that you test in a lab, or you're, let's say, deploying something, developing something like as a final product for users. Okay, so how advanced do you think your project is? Okay, so I guess we have 2 different divisions in the audience here. Okay, I think we have 41 responses, so some people have to give an opinion. So I think we're exactly in the middle. There was no right or wrong answer here. It's more of a perception. But if I can say something that, given the call on what we're doing within ERIES, the frontier knowledge, the curiosity-based driven research, I think I would expect we should be on the lower half of that. A lower score is not a bad thing. It's just more reflective of you're doing fundamental research, not exactly building final products to sell to people. It can develop to that for sure, but it's more a state of where your research actually is. So I guess we're right about in the middle, or you can see the distribution of nobody's doing level 1, but nobody's doing level 9 either. Okay. So the primary audience for the specific scientific impact of your project's results. So who really cares about this? Is this something that just in your area, it's pretty niche and it's very something that that people are very interested in? But maybe it's not for everybody, but it's something important. Maybe it's something for the broader field that, okay, it's a general problem that everybody could really appreciate in my field. Or is it a case of, no, nobody would care, I was just curious and I wanted to have some fun in the laboratory? Again, it's anonymous, so you can say you were just curious if you like. So I guess, okay, we have one person. So I guess we have, I guess we have a good distribution between, a good balance between, let's say, impact, specific scientific impact. I'm talking about technical content here, not about policy things for non-technical people. It would be, a lot of projects are addressing broader issues, and we have a good representation of people addressing specific issues. So that's good to see as well. I think on this case, what you have is 100 points to distribute. And this is where questions will become a little bit more difficult. So which of the following best describes the fundamental scientific impact? So when you break it down to the very basic idea, how do you best describe that? And I think what you have is you have 100 points you need to distribute between those options you see. And so you can give 20 points, 30 points, you can take away points, but let's say it's a weighted opinion of the different options there. You don't have to give points to anything if you don't want, but it's something you can see just by clicking +10 or -10, you can up or reduce your score. So we can take a moment. Don't feel like you have a rush, okay? So the idea of the fundamental idea is to give new data to people, open up new avenues. Okay, these are going to jump around, so I guess I'll wait for a second. Okay, I can see that providing new experimental data and findings not previously available is very important to people, but I guess we really need to follow what Stathis said in the previous presentation then to actually make it available. So we're seeing that the idea of experimental dating new data sets for the community is quite an important thing, which is great and which is fine. It perfectly matches the goal of the project on a more specific sense that we're providing data. We're providing new findings. We're making things accessible, open. We're using these research infrastructures, doing these nice projects that have scientific impact, which we'll see in a second. But one of our big missions is to have new findings and new data, because we'll see in the future that having data, being able to measure things is going to be quite important. Okay. Okay, we have 56, so I guess we're more or less there, I guess. I think we have about 56 people responding right now. Okay. Okay. So, a more non-technical one. Broader societal areas. So where do you think your projects can really impact here? Health and well-being, safety and security, culture and the quality of life, things like that. The same structure again, you have 10 points to assign. Where do you think your project will really have an impact on broader society? You think it's going to help economic development and industrial innovation? Things like that. So I'll give a moment to respond. So we can see people are safety and security, I guess, which sounds dramatic, maybe safety and security, but it's maybe what we're involved in, the idea of protecting lives from earthquakes or tornadoes and things like that. So it makes sense. Social equity, inclusion, sure, okay, but maybe it's not as high in the priority as others. Okay, so 51. Someone's very happy, keeps clicking on like. Yeah, you can keep going. There's no points for this. You're just tiring out your own fingers. Okay, so we have, I think, up to 56. So I guess I think we have 56 people connected. I cannot see the total, but I guess this is more or less everybody. So we can see again the idea of safety and security, infrastructure, urban development, the idea of the built environment. So this is reflective of the projects I showed on a previous bar chart, that a lot of your projects are involved in the built environment. Okay, addressing some hazard for the safety of people. Okay, and the idea of green and sustainable development. So you're picking environmental protection and sustainability. So yeah, it's a fair reflection. So this idea of being able to talk to somebody, to understand what's written on the screen here, you don't need a degree in engineering. This is saying who cares about what ERIES is doing? Well, safety and security cares, or things like that. So this is the idea of what we're doing here. This is a similar but slightly different question. Same structure again. So which of the following would best describe the nature of the potential scientific impact? So who's really benefiting here? Is it the individuals or the communities? Does it really just create new technology that maybe an individual on the street, if we stop somebody outside, wouldn't really care about or wouldn't really be impacted by it? Or is it really just providing a solution to a known problem, maybe in society? Okay, someone went all in on the solution to the known problem. Okay, 43 people. Lots of likes. 2 more people, I think. 56. Okay, now I can say it. So the second last one, informs policy. This is what people really care about. I didn't want to say it before. You're being honest and okay, providing solutions to known problems, but the idea of, or maybe someone is adding in some points to public policy and things like that. We get asked about that a lot. How are you going to impact policy? How are you going to really show the impact of the project? So this idea that it's maybe not high in our minds is something we need to. It's not our fault. It's not something that's wrong. It's maybe just a reflection of how people are thinking, that maybe we need to try and communicate better with what we're doing. So this is what we'll show in a second. Again, another similar kind of thing. There are not so many of these, but I know they're not the easiest things to answer. So considering the potential societal impacts, which area do you think you're going to be most relevant to? So things about environmental, health policy, industrial strategy, public procurement, energy policy, research and development funding programs, or priorities, sorry. Okay, we can see the safety standards certification processes. This is high up on the list. Research and development funding priorities, again. Industrial strategy and innovation policy. Some people were paying attention in the last couple months. So we have 49, 50. I think when we get to 57, we can. So this idea, exactly this, right? So this idea of safety standards, research and development, things like this. So there have been comments in the past that, sure, the work we're doing is great, a lot of technical output, a lot of findings, a lot of great presentations, but unless you can really transfer that into safety standards. So the Eurocode would be the biggest example of that, and we've seen examples of this from the decades in the past of projects, how findings can really be translated into technical guidance. So things like that, innovation policy. So unless we're able to transfer the results of what we have here to something that's a 2-page summary, that's very, you can summarize how many papers, how many presentations into 2 pages of why this matters, who cares, to non-technical audiences. That's what really will drive future programs like this, being able to communicate things like this on a broader sense to really underline the value of something without having to get into technical details and having someone with an engineering degree in front of you. Because in most times you're dealing with non-technical people. And they maybe want to understand, but unless you can explain yourself, it's difficult. So that's our job here in this project, to try and, let's say, hit those targets we have on the top, which makes sense. It's in line with the project, but it's the challenge we have ahead of us. I think we're at the last couple of slides here. At which level of policy making do you think your findings will be most useful? So the local level, is it a local thing in your town? Is it something on the regional or national level? Something on EU directives, UN goals, the sustainability? All levels, you don't really know. So I guess people are, relevant at all levels, which makes sense. You know, you can have things that are relative for your local context, but also can have impacts on the broader context within Europe or also around the world. Yep. So I guess people are expecting to make big impacts everywhere. Okay, so I think we have, this is a couple of options here. Which kind of actor do you think are going to be the most interested from your results? Is it government ministries, regulatory agencies, EU Commission, local government? It's similar to the previous question, but maybe more who is going to care about this? The industry? Okay, so I think regulatory agencies and standard bodies is by far winning this competition. So we'll move forward, just not to spend too much time. I know some people are maybe still voting. Someone is still hitting that like button. So thank you very much. At which point in the policy cycle do you think your findings are going to be of most interest? Identifying and framing policy problem, or is it something like long-term strategy, something like during the ongoing public or parliamentary debate, something that they will be used, let's say, by politicians to describe this, or you're just simply unsure about something like that? Okay, we have a good distribution among all the options. Okay, so I guess we have a lot of people unsure. Long-term planning and also the formulating new policy options as well seem to be the overwhelming majorities here. So which of the following challenges do you see? I think this is a scale between 1 and 5. So each one of these questions you can give a score of like how much you think it is or it isn't. So score it from 1 to 5 or whatever the scale you see. In communicating your project's finding to a policymaker audience, so a non-technical audience, do you think the biggest problem you have is the findings are highly technical and full of jargon, so it's really hard to really just communicate what you have? Identifying the people you need to talk to, trying to translate the complex problem into something, a clear message, so maybe communication issues. Or the fact that findings may conflict with existing policy. You maybe are finding and proposing something that really goes against what existing policy is adopting. Yep, so we can see people are saying findings are full of jargon, trying to communicate this into simple and clear messages. The idea of people using different information channels than researchers, so maybe people focus more on media, social media, online things, not necessarily scientific publications that are more of interest directly to the scientific community. So these appear to be the biggest things holding us back, let's say. Okay, we're 44. Just give another second. Okay, so I think it's quite clear. So then, I thought I had just a few of these. So which of the potential next steps do you think will increase the likelihood of having actual impact? So creating some kind of short, non-technical summary of the findings, so a policy brief, engaging with think tanks, NGOs, so really getting out there and engaging with people, identifying who we need to talk to. Where do you think we're going to have the biggest impact? Finding the right people to talk to or making the nicest document? Collaborating with the right people. What else? Using the engaging more with social media. So things like LinkedIn in the recent years have I think, increased our exposure, let's say, on a much higher level, for better or for worse. Okay. So just to say things like engaging with non-academic community channels. So the idea of LinkedIn, so I think many of you would be aware of this project. We have a LinkedIn page and we try to share and, let's say, keep up to date with what's going on. That gets a lot of appreciation because it's something we can measure. We can say engagement, likes, how many people visit the page, how many people click through to the links to the website, maybe follow up with the data. It's something which, okay, with premium options you can pay and obtain all of these data from channels like that. And it's something you can really convey engagement. Because when we're under evaluation and trying to say that, yes, people are very interested because a lot of people came to our special sessions at conferences, a lot of people read our papers, but how can you really measure that immediately, not in 5 years when maybe the research is more diffused? Things like engagement online is a good way, also because it reflects maybe non-technical audiences, and you can see that with these kinds of tools. Is it people coming from engineering, academic backgrounds, or are there people coming from industry? LinkedIn can tell you these kinds of things. So this is something that we're already seeing is quite useful and helpful in that sense. Okay. So if we were to do any of these, how much would you like to be involved in this kind of stuff? Saying, no thanks, I'm going to stick to the technical stuff, or I absolutely want to be involved in this. So this is someone really wants to be involved. Okay. Okay, so I guess people are quite positive about this. I was expecting a lower score. And we can see the tails of the distribution there are leaning more towards, yes, people would like to be involved, but I guess it's more a case of knowing who to talk to and finding the right channels. Okay. So this is just the last slide. Open questions. You can just raise your hand and we can use the microphone. I think you can type into your phones directly and it will pop up here. But do we have any questions or comments from the audience on this idea of policy and impact at this point? While I'm waiting, I'll go back to a couple of slides I have here. No? People are shy. So coming back here, so this idea of impact and how to translate this into the right audiences, right? So what we talked about already internally with some of the committees we have is, sure, the idea of communicating, breaking this down into a technical, non-technical impacts, the bigger picture, who really cares about this stuff is important. I think everybody knows that. And one thing we want to do is we will contact you. I decided not to do this during the conference because maybe you want time to reflect on what this is, to get 2 to 3 lines of what you think really matters about your project, right? So what we'll try to do is collect all of this and try and aggregate this into the most synthetic document we can. We will collect, I should say here. And the statistics as well we're collecting, so the data I have from the previous answers will also help in that. So it will maybe help justify the idea that maybe 60% of our audience thinks that this is important, and maybe people feel this is more useful and so on. So in terms of the questions we're going to pose to you, we'll have ones on scientific impact. And the question is going to be phrased like this. You will get this by email, and we'll have, let's say, a form you can respond. And if you don't respond, we will email you again. And we will be quite persistent and determined to get this stuff, because I think we can agree that it's important. So the idea of please explaining what the fundamental scientific impact of your project result will be on the research community, which I think a lot of us can do this. If I go to any one of you in the audience and I say, who cares? Well, why did you do that? And you can talk to me for 20 minutes and say, this is really important because of these reasons. And all of in your presentations, this is the purpose of all of those, right? We've divided this into 2 sections. We said this, okay, scientific impact, we can all talk about that. And people can get very excited about their project. But we want to have 2 ways of doing this. Specific scientific impact. So let's say I'm working on a specific topic. Try to give 2 to 3 lines of someone who works in that specific area. Not, let's say, not earthquake engineering, wind engineering, but someone within engineering, within that specific topic. What did you do? 2 to 3 lines, I solved this problem because we saw this. That's all we need. But then the general scientific impact, it's a bit more general so that engineers can still understand it. It's like, okay, we're looking at this problem, and this is what we did, and this is what we found. 2 to 3 lines to really convey why you did that. Like, why did you create 5 specimens, break them all this way, test them all like that, and use this configuration? What were you trying to address? So you could talk to 2 different audiences there. If you're talking to your immediate colleague who works on that topic and you read a lot of their papers, you would maybe be a bit more specific. And the other ones, you would maybe try to keep it a bit more general to convey the overall importance. And then we switch to the societal impact, okay? It's the exact same thing. But just imagine you're talking to a non-technical audience now. Imagine you're talking to one of your siblings, your cousin, someone you meet to play football with. So the same thing of why you did this project. Someone says, why did you test that? Well, I was trying to solve this problem. I'm not going to give any examples because I think maybe I will bias the responses. But this answer should be understandable to someone who's really non-technical, your parents. Like, why are you doing all that stuff in the lab? Because I'm trying to solve that problem that we can see after all of these windstorms or earthquakes. you see that stuff on the news, we're trying to fix that. That's the kind of the impact you have. And then the last one is the guidelines impact. I think this one could be quite useful because it really goes for the specific parts. And I think a lot of us could do this already. Maybe it's a bit more difficult for some projects, but the idea of saying that, can you point out in a building code like Eurocode, ASC, anything around the world where I'm trying to solve that? Because in Eurocode 2 part, this is just a random section. I don't know what's written here, but so apologies if anybody was involved in writing this. I'm not trying to attack that. I'm just saying that, okay, in Eurocode something, Eurocode 8 part 2, I'm trying to fix this problem because we've seen in the past that this is it. So this is really pointing out which parts we're trying to improve and so on. You can make reference to the existing Eurocode or the new generation that is about to be introduced if you had time to read all of that. Okay. So you will get all of these in the upcoming days, I guess. You'll get an email, and if you don't respond, you will get another email and another email. Okay. So that's it. Any questions or comments? Yes, Girma.
I was wondering, we score low on the policy side of things, but we are yet contributing a lot to building standards and codes and safety of the society.
Yep.
Is it the articulation of what we do that is lacking, or
Yes.
is it really we don't contribute to the policies? For example, on the other side of the continent, there's a lot of integration of engineering with social sciences, perhaps in addition to engineers, scientists, we have to start bringing social scientists who are good in articulating and showing the impact of the society. These are the things that I wanted to comment, and it's also a question,
Okay.
Okay, thanks.
No, thanks very much, Girma. It's a great point. The idea of the impact. I'm not saying there is no impact. Maybe we just need to ensure that we don't miss an opportunity to communicate it well. Because if we don't, we're shooting ourselves in the foot. We have great data, but that's all the data you're going to have for the next couple of years, because maybe we won't have so much opportunities there. The second idea about involving social sciences and maybe communication, the idea of using social channels, maybe communicating better, was one thing that was mentioned on the survey just now, but also social sciences and maybe people's perception. I can see Antonio here. We were at a workshop late last year, and there was some involvement from social sciences and people with very non-technical backgrounds, and they had some great impact or great insights on how communication really matters. So one of the things was risk, how if you say something has a probability of ultimate damage state, how you phrase the performance. You could say the exact same thing 2 different ways in mathematical jargon, and one has a very alarming effect on people who are non-technical. The other one sounds very reassuring. The idea of return periods, like 1 in 500 years, that sounds very reassuring. But when you say 10% probability in 50 years, well, that sounds a lot worse. But mathematically, it's more or less the same thing. So that kind of stuff could be quite useful. So, yeah, I guess engagement with some of those people wouldn't harm. Any other question or comment? No? Okay, so we can go to the, oh, sorry.
I think, engaging with social media will be key to this to the broader community. And you've been doing this profile series on LinkedIn, and I think from the outcome of the answers, we could also have the user groups making a small video explaining what they have done and what are the impacts and so on, and that would be another way to put it out there.
That's a great point, and thank you for mentioning that. So on social media, the idea, we had this in mind at the beginning of the project to include something like a profile series to show the people who are involved in what they think is valuable about this. That deliverable was due maybe 1 or 2 years ago when we didn't have a lot of technical results. A lot of you are maybe still planning your stuff, so it was maybe a bit premature to ask any of you, what do you think the benefit of doing this was? Because the response would have been, I don't know, I haven't done it yet. So what we did was, it was very internal. So a lot of the people you're involved with the laboratories were saying what their perspectives were. And Hanny, who is sitting somewhere here, has sent an email to you in the last couple of days saying that we need your responses now. So something as simple as 2 lines I think this is a great opportunity. I think this is very useful for this X, Y, Z. A simple photograph. If you don't have one, we can take one. It's not a problem. Because this is really appreciated. It really shows that diversity of the people, the opinions, giving center stage as well to the people and giving visibility to all of you who are involved, not maybe hiding behind publications, data, DOIs, which of course is important, but also gives the human aspect as well. This was a comment that was raised as well in our latest review, that it was a compliment that we've created a great community, and we're very fond of the users. There's a great connection there, and how to maybe translate that and underscore that, and profile series and things like that, and videos, as you just mentioned, Antonio, are of course a great way. So, yep. So please respond. Also, if you don't respond to that, we're going to be very energetic in our pursuit of a response there. Any other question or comment on the policy side of things? No? So I guess we'll move to the last slot we have. I have 10 minutes. I thought we would have too much time, but I guess we're running out of time. So the future outlook for ERIES, right? So this is something that was mentioned, and I think I've talked to some of you about this. So this was kind of a tricky slide to make because of how many years I had to report on it. But if we look back to the history of some of these things and how the development of this, so Professor Calvi had mentioned that one of the first ideas of these came in the early 90s. I won't mention a point of my education I was back then, but I was a little bit younger back then. So the idea of the history and the heritage of these kinds of programs and the evolution over the years, you maybe have heard some of these acronyms being mentioned now. There's a good history there. Maybe there's some gaps, maybe some things, some gaps along the way, a lot of overlaps of projects, but there was a lot of and maybe there's some missing. If there's anything missing and people know of projects that are not on this slide, let me know and I'll be happy to update it. But it creates a great picture of heritage, of involvement with maybe seismology communities in different projects. Now we have great involvement with the wind communities and so on and so forth. The idea of pre-EC8, so the pre-Eurocode 8, something back in 1993, which led into what we now use, at least in the earthquake engineering community, what we can see there. I'm sure if I ask a lot of you in the wind community, you can maybe relay something quite similar. We could populate something there as well to show a lot of progress, a lot of technical progress in code development, and a lot of involvement in all of the funding programs. So the idea of FP3, 4, 5, 6, you can see we're very present and very, very continuous in that. Okay, so this is the idea of what we want to achieve. This is the table of the exact same thing, but it gives a more detailed view, has some titles, some idea of funding levels and so on. You can find all of this online. It just takes a second to Google the grant numbers and all of this kind of stuff. But it's this kind of heritage and this kind of continuity that we maybe need to sit and reflect and think, what do we want for the future? You know, a lot of great stuff has happened in the past, a lot of great results, a lot of great impacts, but where do we want to go from here? Okay, so this, we're going to flip back to it's not going to be as heavy as the previous Mentimeter, but it will be of a similar vein. Oops. So we'll have a new QR code, so it's going to be, you need to scan it again. And we do have just 13 slides here. So let me pop that up. Someone hit the like button, great. Still a couple of people taking photographs.
How long will it be?
How long? No, 13 slides. It's not that long. We'll make it for coffee. Okay. How easy or difficult was it to understand what transnational access was? This is us. I imagine for some of you, okay, so it was quite easy. Maybe you have a lot of experience. For some of you, it was maybe quite new, the idea of what does access mean? What is transnational? All of this kind of stuff. So, okay, this is good to see. It means we were modestly successful in the way we presented the project. Okay, so we can have 58. Okay, I think we've a good amount of responses here. Do you think you could have done your research at your local institute if you didn't have transnational access? Could you have done it there? So probably yes, no. It would have been challenging. Maybe we could have done it, but we maybe needed to invest and buy some new equipment, things like that. So I think a lot of you are saying no. You needed opportunities like this maybe to move around, interact, collaborate with different people to get your research ideas, let's say, into practice and test some things out, which is good to see as well, because it's responding to the call of people who are maybe coming from institutes, areas of Europe who don't necessarily have facilities in their local institute, but they shouldn't preclude good ideas being conducted in centers of excellence or centers of that have been constructed in the past. So this is a great response here. How likely are you to participate in this kind of activity in the future? If anybody says no, I want to know why. This is obviously a great result, but like being a slight perfectionist, I'm wondering what happened to the point 2. Okay, so we have a very good, positive response, which of course is a simple question, but nice to hear it anyway. Which specific aspects do you think you could improve for the user groups? So you, not necessarily as the access providers, but the user groups who are experiencing this. The collaboration and conference, the call for application, the way we handle the process, those kinds of things, communication with access providers, travel, data management, publications, or just everything is great as it is? Okay, great. Thank you, whoever said that. Okay, I think a lot of people are happy, but a couple of themes are coming up there. The idea of data management, travel and subsistence, things like that, calls for applications. There are some things that we know that are not, could be better, but it's a learning process there. Just to comment on the travel and subsistence idea, to give some perspective. So we attended a workshop in Brussels area this year where we had different ERIES was represented, but also other projects like this. A request was made saying that this is common to every project because what the EU says is don't quote me on this, but the attitude is, let's say, you have to follow your local regulations. So if someone's having access at the university in EU Centre or in Pavia, for example, our local regulation that I, as someone who works there, need to follow applies to also the people visiting. Likewise in Portugal, likewise in France, in the UK, and so on and so forth, right? So it's very different experiences for different people, depending on where you go. Maybe it was very smooth, very easy. Maybe it was a little bit more difficult. And that's not exactly great, and it's not exactly uniform for everybody. So it really impacts the experience on things like that. There was a request made that basically, could you make a document that kind of gives us a more centralized document of guidelines that we can follow and refer to that, instead of having to refer to our local ones. So other groups are reflecting this as well and requesting that this be made. They didn't really give an answer, at least a concrete one, a yes or no, but at least they're aware of this. It's something that that people were discussing. It's a nice story, so I've told it a couple of times, but to give some context, some other projects, they were looking at Arctic or Antarctic research, and one of the ideas was that people should pay for their costs up front and request reimbursements, and that seems to be the normal way, and I think many of you will follow that model. And one of the other projects raised their hand and said this is not possible because a one-way flight to the Antarctic costs 20,000 euros. So maybe it's a bit more of a tricky situation to get around. So to give some context there of how things are going on a European level and how maybe we could tackle that in the future. The idea of data management, okay, I think we realize it's important, and we could certainly do things better there, and hopefully we can make a good effort on that. So the next question: how important are projects like this in supporting the financial stability and research longevity of the research communities? How important do you think this is? It's great, it's nice, but we could do without it. It's let's say an extra thing, or you think it's very fundamental? So it's not so much or very much? So as expected, I think people are responding quite positively, saying that this is pretty crucial for the longevity and stability of communities like this. So it's not a surprising result. in this project, we looked at 3 different hazards: wind, earthquake, geotechnical, calling them specific hazards, but let's say areas, or I think we call them hazards. Which ones do you think you could include in future projects? This is just an open question to give people idea to understand where people think other hazards could be addressed. So things like flooding, landslides, tsunami, hailstorms, drought, wildfires, things like that. Some of these are more recent. You see them on the news quite a lot. The idea of hailstorms, drought, wildfires. Unfortunately, it's happening quite a lot. And as far as I know, not very present in projects like this. So do you think us as maybe natural hazard engineering community could expand and look at things like this? So the idea of flooding, landslides, okay, this is more or less what I expected people to. Okay, we have 40 answers. Give it just another second. Okay, so of these exact same hazards, how ready do you think Europe, or let's say potential partners in a project like this, are ready to actually address them? So maybe you think lightning or hailstorms or landslides are very important, but does anybody actually address that? Do you know of laboratories who can actually do that? Maybe tsunamis are very important, but nobody can actually address them in Europe. Or eligible projects for funding programs like this. Sea level rise, of course, maybe it's important, but nobody's actually built a research center to do it. So flooding, I think, is one of the more popular ones here. That, yes, you know of things like that. So it's just to give some context, because I can see it's actually now moved to the bottom there, the idea of hailstorms. This is something, if you speak to the reinsurance industry, they're quite concerned about this because of the frequency and the level of damage they have because of these, especially around Europe. The idea of all of a sudden you have a hailstorm in the middle of summer, and the amount of payouts for insurance for car windscreens and roofs and stuff like that are shooting up because they really don't know how to model the vulnerability. It's something they're trying to ask a lot of questions of. So maybe it's something that obviously not for the immediate future here, but a potential thing for the future of, can anybody actually test this stuff out? Can we do something like that? Maybe not the next project, but the one after that. Coming back to terminology, which is we've seen some of this already. So how familiar are you with this EU terminology? We saw from Stathis' presentation, which is no fault of his own, but it's more a reflection of how EU policy and EU call documents are structured. But it's full of acronyms and full of very different things that sound the same but actually mean slightly different things. But this is to give you an idea of how familiar have you ever heard of FAIR before? Okay, you have just now, so if anybody says no, then you weren't listening. Or the European Open Science Cloud, the idea of ERIC, what an ERIC is. Okay, so more than half of the audience was paying attention to. So I guess we can say that people are reasonably familiar with FAIR. Things like the European Open Science Cloud, something like ERIC, the European Research Infrastructure Consortium. I had a feeling the responses were something like this, that maybe never heard of it, not so familiar. But the first one in particular, those things are becoming fundamental in calls for the future. The idea of ERIC's involvement, so I would strongly advise you to understand what that stuff is for the future if this is of interest to you. The idea of FAIR as well, okay, we can see now from the previous presentation, because we had a lot of slides on it, we can see that's becoming more important. EOSC as well, the Open Science Cloud. Maybe you've never heard of it before, but these are things that are popping up a lot more in calls, and they're not going anywhere, so it's something we maybe need to work on a little bit of that. Where do you think the biggest impact of ERIES and these kinds of projects is? Is it the funding it provides to sustain research, the network opportunities, the new research ideas it provides, opportunities for young people? I think this is a scoring. You have the points again. The data it produces, yes. So the networking collaboration opportunities, I think that's something that's quite appreciated as well from that map I'd shown before of the, let's say, interaction between different countries, different places from all around Europe, the different cities, not just big cities, but also maybe more remote places that are strongly interacting with other people around Europe and the world. So this is a great thing to see as well. The data as well that it produces, and we need to make sure that it's not just producing data, but making it available as well. Also the funding as well, it provides to sustain research. I think this is good to see as well. So we're 50, I think we can move because we're a couple of minutes over time. This is not a trick question, but I'll tell you why I'm asking this in a second. So which do you think how to measure success? This is something that comes up in evaluations. How do you measure the success of a project like ERIES? Is it the total number of gigabytes of data you produce? Is it the number of people involved? Is it the number of papers? Which do you think are the most important things? And then I'll tell you which ones the Commission is currently using. Yep, so we can see people are quite the impact on international standards and guidelines. So we had 29 citations, the quantity of data. Number of young researchers. So I can begin to tell you now, one of the principal measures of success, and let's say how they evaluate transnational access, is actually the number of access days and number of users provided. This is how you get measured. And then what is an access day? Is it when I just went to see the specimen, when I went and instrumented the whole thing all day? These are all a metric of days of access. This is what, because it needs to be generalized terminology they can apply not to engineering projects, but also to other fields as well. And this is one of the metrics that they use. So the idea of impact on standards and guidelines, sure, but how do you measure that? Like, what's the number? Or where can I find it? So sure, it is a great measure of success, but how can you quantify that? Because a lot of things, the KPIs, the key performance indicators, quantifiable metrics, stuff like citations is easy. There are databases online that can help you out with that. Stuff about the number of young researchers, okay, that just took some digging of stats that we had, and I could produce that slide I showed you before. The gigabytes of data, okay, that's a rather silly question, but it's useful, but maybe not the best indicator or the best predictor of success. But to say that the access days is one of the big metrics that they're interested in. I think this is an open question, but given that, could you suggest any way of doing it? So if you have a better way of doing it, you can type it into the box right now, and let's see if we can come up with a better way and propose this in the future. So don't be shy. You can say the number of emails I send, or something like that. Okay, someone's saying like, but maybe this is the probably number of researchers, number of countries, number of universities. Yeah, these are good metrics, and this is definitely appreciated as well. The idea that we can reflect the number of researchers and the number of people involved is, and especially the involvement with industry, because it's a reflection of how we can translate our research into impacts on actual society in a technical sense. Early career researchers, yeah, that's a great thing. They're very confident of that. Number of patents, yes. The difficulty with that is that it will tend to come out way beyond the project's lifetime. So the impacts of citations and, let's say, the longevity of projects will be evident maybe 10 years later or maybe 5 years later. So it's hard to track that, maybe on the more immediate when you're trying to have your project evaluation. So, okay, we have a lot of, I can't keep track of all of these, but keep submitting them, and we can go through them later. Likes on Mentimeter, thanks. Social media posts, data downloads, yeah, these are all great ways of measuring things. Okay, so we have Number of follow-up projects. Okay, people are still responding, so I guess we have, I think, 1 or 2 slides more, so we can go for coffee then. So number of researchers, the number of people involved. So I think to quote a movie, it's not about I forget exactly the thing, it's not about the end goal, it's about the friends we met along the way, basically, so. Okay. And I think this is the last slide, so questions from the audience. Any things we want to talk about? So this is maybe getting your opinion of what you think is important, what you think could be done in future calls like this, and maybe terminology, quantifying measures, stuff like that. So you can pop in some questions here or just put up your hand. We can, maybe it's a bit more immediate. So any questions, comments from the audience? Everybody's very shy. Okay. So I guess we can close the session, go for coffee, and thanks again for your attention.